We're now going to use radiocarbon dating and logarithms in that to help us find some more information. And in particular, radiocarbon dating is based off the carbon-14 molecule, which is radioactive. And if it doesn't replenish itself, then it's going to decay, and its half-life is approximately 5,700 years. So the first thing we're going to do is we're going to find a K value. So 5,700 equals minus the natural log of 2 over K. Let's just swap places here. This means K is equal to minus the natural log of 2 over 5,700. So we get out our calculator, we clear it all the way out, and we'll do 2 natural log negative divided by 5,700, and that gives us this number, 0.0001216, but I'm just going to store this in the calculator for later. So we've stored in the calculator. So the next thing that I'm going to do is I'm going to look at this. This means that the A of T of carbon is equal to the A naught times e to the minus k 0.00001216 t, but I'll use the one in my calculator. I just want to write this out. And so if I have this, then all I have to figure out is how much time has passed, and that'll tell me how much carbon is in something. So I can use this to tell how old something is. When was it created? When was it used if it's got carbon in it? So in 1960, a group of specialists from the British Museum in London investigated whether a piece of art containing organic material found in Tutankhamun's tomb had been made during his reign, or as some historians claimed, whether it belonged to an earlier period. We know that King Tut died in 1346 and ruled Egypt for 10 years. What percent of the amount of carbon-14 originally contained in the object should be present in 1960 if the object was made 194 years before King Tut's death? So here's what we know. King Tut lived for a total of the 1960, he ruled from 1346, and he died then. He ruled for 10 years. So he ruled from 1336 to 1346. But we're worried about 194 years before that. So from 1960 to 1346 BC AD, this means we have 1960 plus 1346, plus we want to take into account this additional 194 years, so that's my t. So 1960 plus 1346 plus 194 gives me a t of 3,500. So now we just go back to that earlier formula. A of 3,500 is equal to A naught, which is what we don't know, times E to the minus k, or just to the k, we've got a k up there already, k is negative, times 3,500. Well, knowing this, there should be, all we have to do is evaluate this piece right here, and we will get k, let's recall our value, times the 3,500. We're going to raise e to that power, and we get 0.6533 A naught. So there should be 65% of the original carbon, 65.33% of the original carbon, in order for this to be from 194 years before King Tut's death.